list of integers nested list. Yeah, so we are giving this kind of a nested list. So what is inside? It is a list of a nested integer class. Yeah, so we are giving an array nested list, and inside of the array, inside of the list, it's going to be a nested integer class. So this is the interface of the nested integers. So each element is either an integer or a list where elements may also be integers or other lists, because it is a nested list. So inside the nested list, it can be a list, or it can be integers, or it can be a nested list. So the depth of an integer is the number of lists that it is inside of it, and that it is inside of. So for example, the depth of this number 2 is 1, and the depth of this number 1 is 2, because it is inside another list. And similarly for this one, the depth is 2. So the depth of an integer is the number of lists that it is inside of. For example, the nested list, this one has its integer's value set to its depth. So we're going to return the sum of each integer in nested list multiplied by its depth. So let's just check what is the final return. So we have such kind of integers 1, and for this one the depth is 2, 1 times 2, 1 times 2, and for this one it is 2 times 1, and this one 1 times 2 and 1 times 2. So the final answer is going to be 10. I think the easiest way is to use BFS to solve the problem. We just need to understand what we are giving. We are giving this kind of a nested list, and inside it is nested integers. And for this nested integer, it can be none, or it can be an empty list, or it can be a single integer equal to a value. But there are also some methods. It is integer. It is just used to check if this is an integer or this is a list. So return true if this nested integer holds a single integer rather than a nested list. Otherwise, it's going to be a nested list. And we can also use it to add elements. So to hold a nested list and add a nested integer element to it. And there's also some set integers. We can set an integer to hold a single integer equal to a value. And we can also use a get integer and get list. So there's a lot of methods. So this get integer is just to get that integer, and this get list is just used to get the list. So it's gonna return a nested. List. We are giving so much method, but it doesn't mean we have to use all of them. Maybe we just needed to use some of them to solve the problem. So let's just prepare the BFS pattern. So we're gonna use a queue. So I'm going to prepare an empty queue, and it's going to be a double-added queue. And I want to check all items inside the nested list. Inside the nested list, there's going to be the nested integer class. But I want to put it inside the queue first, because after that I'm going to use the BFS to check if it is an integer or if it is a list. And by that way, I can calculate the depth, and I also get that integer, and I can calculate the final result. So I'm gonna append all those values. So it's gonna be this item and a depth. So from the beginning, I'm gonna append a depth of 1. So for example, for this one list, I'm gonna append 1. For this 2, the depth is gonna be 1 as well. For this 1, the depth is gonna be 1 as well, because after that the depth is gonna be increased. Now this is our queue. Now we just need to check the queue, and the node and the depth is going to be equal to q.append, q.pop. We just need to pop the node and the integer. So this node can be a nested list. Yeah. Now this node is just like a nested integer class. We can check if it is an integer or not. So if not dot is integer, so this means it is an integer. We can update it to our final result. It's going to be d times not dot get integer. Otherwise, it means it is a nested list. So let me just prepare the final result. It's going to be 0. Yeah. Otherwise, it's going to be a nested list. So let's just check it. So for item inside the d dot get list, and we need to append it inside of the queue. It's going to be this item, and the value going to be d plus 1, because it is a nested list. so the depth is going to be increased. Finally, we just need to return the final result. This is a for item in d dot. Yeah, so what is wrong? We have the get list. Integer object has no attribute get list. It is not d.getList. It is not. I think this is a typo. Yeah, it should be the not.getList. Not is a class. Yeah, now as you can see, it works. And now let me just submit it to check if it works. Yeah, as you can see, it works and it's pretty fast because this is just a BFS problem, and the time complexity is just dependent on the how many integers inside the nested list. It means the total integers. So the nested list, the length is 100 and the value is the depth is 50. Yeah, so the length is for each of the nested list, the length is 50. So how many of them? There are 50. So 50 times 50, it is 250. So that's going to be the time complexity. And because we are giving a nested list, it's going to be an array, and the length is going to be 50. And inside, there's going to be another nested list, and the length is going to be 50 as well. But how many of them? It's going to have 50. So yeah, for this list, it's going to have 50 items, and the nested depth for each one gonna be 50 as well. I think it's gonna be 50. And inside of this item, there's gonna be another. Yeah, but how can we calculate the time complexity? The depth's gonna be 50. Yeah, this is difficult to calculate. So there are going to be 50 items, and the depth is going to be 50. So this is 50, and inside is going to be 50. So the values of the integer is this is okay. So the maximum depth of any integer is less than or equal to. The maximum depth of any integer is less than or equal to 50. Yeah, I don't know how to calculate the time complexity according to the constraints. So I have the length is 50, and the maximum depth of any integer is less than or equal to 50. Yeah, I think there's something wrong. It should be any list instead of any integer. Oh, any integer, it means there's going to be an integer. This integer, the maximum depth is 50. Yeah, so the time complexity is going to be really big, but I don't know why the testing cases just to make it not like the constraints. So for example, they're going to be inside this array, there are going to be another 50 arrays, right? There are going to be another 50 arrays. So inside of this array, there are going to be another 50 arrays. And inside of this array, there will be another 50 arrays. And inside each array, there are going to be another 50 arrays. So this means the time complexity is going to be really big. Yeah, so I will not analyze the time complexity about it because because I think the constraints is not enough to analyze, because basically the depth for each of the integer, the maximum depth, if it is 50, yeah, it's gonna be really big. So I think that's all for it. Thanks for watching. See you next time.